So right here, number 23, we are going to solve this equation for m, get m equals some number that makes this thing true. Now we know how to do this. We get the LCD, everything's already factored, so we'll get the LCD here is m, and then we have to think what values have to be excluded. What values of m are going to make this denominator 0? Well, the one here is going to be this. We have to say m cannot equal 0, because if m is 0, we get the denominators being 0 and then division by 0. So what we're going to do here, according to the general process, is this. So let's do that. So we will put 6m, we'll put the LCD here, minus 2 over m, we'll put the LCD here, and then we'll put it over here on the right side. Now in doing so, all these denominators cancel, right? So that m will cancel with this one, and we are going to be left with 6 times 1, which is just 6, minus, now let's cancel here, so that m will cancel with that one, and we're going to be left with 2 times 1, which is 2, equals, nothing cancels over on the right side, so we'll just get 12m. And let's just go on here. 6 minus 2 is a 4, equals 12m. And let's divide by 12. We'll get 4 over 12 is equal to m, or that m is equal to 1/3. So here we are at 25. Let's do this the same way. First of all, we have a rational equation. What's the LCD? The LCD here is y. And what values have to be excluded? We can't use a 0, right? Because if we use 0, we'll get division by 0. So we're going to say y cannot equal 0. I'm going to circle this so I can see it, find it later. And now, according to our general procedure, we multiply everything by the LCD. So I'm going to put the LCD next to every original term right here, and right here. So let's do it. We're going to get 7 over y times y plus 4 times y equals 4 over y times y. Now, these denominators are going to cancel. This y will cancel with that one, leaving us with 7 times 1, which is 7, plus, now nothing cancels here, right? Just 4y equals, but those y's are going to cancel. So what we're left with then is 4 times 1, which is 4. Now we can solve this equation here just by, let's subtract that 7. So we're going to get 4y equals, now 4 minus 7, negative 3. And then finally dividing by 4, we'll get y is equal to negative 3/4. But right now we know this is only potential. So let's take this negative 3/4 and just run a quick check. Is this an excluded value? The only excluded value we have is 0. We got negative 3/4, so we're okay. We can now just conclude that the solution to this equation is y equals negative 3/4. So let's move on to number 29. Now number 29 is pretty much the same as what we've been doing, with one difference here. The LCD is 13, and in this case there are no excluded values. There no values, no numbers are excluded, because what's going to make this denominator 0? Nothing. It's never 0. It's 13. So we're not going to exclude anything. So what we'll do, as we always do in solving these equations, we'll take our term, 4 over x times 13, and multiply it by the LCD, plus 13 times x equals 17 times 13. Right? You remember what we do here is we take the LCD and write it alongside each term. So I got 4x over 13 times 13. I wrote it here. Plus, put the 13 here or here. I put it in front. 13 times x equals, now put the 13 right here, right? You put it next to the first term, the second term, and the third one. Now, in this first term here, these 13s are going to cancel. And we're going to get 4x times 1 is 4x, plus 13x equals, and when I multiply that, I got 221. And when we add these together here, 4x and 13x is 17x equals 221. We're going to divide by 17, So 221 over 17, x equals, now I know this is going to be 13, and here's how I know this. If you look back up here to what we did, we got 221 when we did what? We got 221 when we multiplied 17 times 13. So that 221, you know what, I'm going to write it over here, that 221 is really equal to 17 times 13, and then if I divide it by 17, they cancel out. So I just happened to see that. Otherwise, if you're not sure, do it on your calculator. Now let's run a quick check. Is 13 an excluded value? We always need to check. So we come back up here, we see there are no excluded values. So 13 is good, and we are going to claim that that's the solution to this equation.